Good morning. So now we are going to begin our session, third session for data science. I'll share my screen first. Yes. So today we'll discuss something about regression and SVM regression and those kinds of topics. Ridge regression. The topics for regression are we'll have a quick recap of regression, then we'll discuss something about simple regression, ridge regression, SVM regression, a little bit about cross validation and nested cross validation. So what is simple regression? Simple linear regression. So this is the model for simple linear regression. Fx is equal to b0 plus b1 plus b1x, b1 times x. b0 and b1 are the coefficients and fx is the function that models the behavior. So y is equal to fx is the thing that we have to minimize. So this is the total error. So this is also called SSE, sum of squared errors. So this is the error and this is the square term and this is the sum. The good thing is that you don't have to solve these equations. Computer will also do this for you. Every minimization problem is done automatically. Machine learning algorithms will do that for you. Now we come to ridge regression. In ridge regression, the equation changes to b0 plus b1 xi1 plus b. So you need not worry about the equation. It's just that the x, the feature that was there in the simple regression, it is now denoted by a vector. So it is being spread out. We can have weighted coefficients multiplied by the x values. So the procedure is still the same. We have to minimize the error y minus fx squared error. So it's just that we can replace fx by this equation and it comes like this. So these are the coefficients that we have to minimize. So in ridge regression, we basically introduce a regularization term. So this is the regularization term. So squared coefficients, C is the term. This is what makes it ridge regression. We minimize this. In case of similar values, it chooses the coefficient which are minimum, that is close to 0. This is something that we minimize. So it favors smaller coefficients. It is controlled by parameter C. We'll discuss about this C in the nested cross validation problems. Again, we need not solve these equations. The computer will automatically do that for you. Machine learning algorithms will do that. You just need to know these algorithms to know the basic maths behind what's going on in the algorithm. So this is something, this is a graph for ridge regression y minus fx squared. In support vector regression, we introduce a epsilon term. So y is equal to fx here, and post that there is a linear curve. The only difference is this epsilon term between SVM regression and ridge regression. Now we'll talk about cross validation. In cross validation, we make equal size 10 folds. We choose 9 training fold and one of them is a test fold. We keep on moving the test fold. We measure mean and standard deviation. So we divide the entire data sets into 10 fold. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can choose a different number as well for these folds. We can have 5, 7, 8, these kinds of folds as well. But generally it is 10 fold. We have 9 training fold and 1 test fold. So this test fold keeps on moving and changing. This becomes a test fold, the next validation, and these become 9 training folds. Then this again becomes test fold, and this keeps on happening until every set become a test fold. So we compare the average out of the sample cross validation. Now what happens in nested algorithm, nested cross validation? We need a data set, we need algorithm, and we need a evaluation measure. We also need a parameter that needs tuning. For here we call the parameter as k, and we keep changing its values from 1, 10, 100, 1000. Actually we don't know the value of k right now. We'll know it from the algorithm itself. So here is the division of the data set. We again divide the data set into 10 folds. One is the test fold, and among the 9 training fold, we choose one as validation fold. We keep rotating the validation fold among these folds. Now here validation fold will keep on moving until we choose the K with the highest average validation performance. Now this becomes the validation fold. In the next phase, this becomes a validation fold. So this happens for each test fold. So this will happen for 10 times again. We divide the data into 10 folds. One is reserved for the test fold. We reserve one for the validation test in the 9 training folds, and we choose the values from 1, 10, 100, 1000, 10,000. In this case, 5 measurements, and we do 9 into 5, that is 45 measurements for each of the fold. And then we repeat 10 times from the step 2 again. For each, again we measure mean and standard deviation. This is what we have done. We have discussed something about regression, simple regression, ridge regression, SVM, CV, and nested CV. Thank you.